decided to with you here today to discuss about my thesis on implementing FaaS runtime with Intel SGX. My name is Will, and this project is conducted in ICT Lab, USTH, under the supervision of Mr. Lin Chuya. And I'm working with the CPR team at Lab, guided by Dr. Raymond Boris. So here's the next 15 minutes. We'll have this 5 content. First, we move to the motivation of our project. The function and the service is a cloud computing model, which attractive for developers because it simplifies the development. Because it simplifies the development, offers scalability, and especially it reduces the cost of the provider because it only charges when the function is run. However, this model poses various challenges like global time, resource overhead, and what we consider the most is a security challenge when we handling sensitive data inside the FaaS model. So there's a need for us to research on this topic and to address the confidential computing problem. And in FaaS, as you can see here, the hacker could conduct an attack to the FaaS runtime, or an admin could like use the root access to the user program when running on the FaaS runtime. So by that, the main goal of our thesis is to enhance security in serverless workflow by integrating Intel SGX into the inline framework, which is developed in-house at IRIS. To go further by that, it is critical for us to understand the inline workflow and know how to use the Intel SGX SDK to move critical components into the Intel SGX. And next is to protect the sensitive function data from unauthorized access like root access, not user access, and especially the side channel attacking by using Intel SGX. And of course, lastly, we have to evaluate the performance of the new system we implement. Before I go to my contribution, I will talk about the background part so that you could briefly understand what I will talk into contribution. So first is a function and a service. What is it? Is, like I said earlier in the introduction, it is a cloud computing model option. So that allows developers to host a piece of code, a function, a building block of a program on the cloud without worrying too much about the underlying infrastructure. By that, it will only charge you when the function is executed and how the resource is used. This will allow users to fine-tune the resource allocation and optimize the cost of their budget. Compare the FaaS with the traditional cloud model. Imagine traditional cloud model like infrastructure as a bit or IaaS, like a water tap. When you open that water tap, it will always run, and you have to do multiple tasks on that water tap, like wash face, brush teeth. Why FaaS is in contrast, when you open the water tap, you do one specific task and you close the water tap. Here is the simple function and the service architecture. The developer interacts with the application gateway, so that from the cloud computing model, the FaaS service provider will be triggered by this event trigger. This event trigger could be an HTTP request, a timer, or maybe a message queue. That will help you how to scale the what resource is needed to execute the function. And with this simple architecture, Nline is developed at IRIC, and it will provide you a more way to manage the workflow. The workflow is a step-by-step guideline for the system to run the function chain. It improves the isolation and communication by having multiple message queue here that will manage input, output, and errors. The orchestrator will push the code into the orchestrator to manage runtime and workflow, while the runner will execute the function. By using ductile JavaScript engine, however, we only support the JavaScript code. As I said earlier, the orchestrator will manage the workflow and push the code into the Nline runtime and share message queue, so that they will have the Nline runtime will communicate with this share message queue, and each function in this runtime will have a local message queue that help you run the function. However, as you can see here, the Nline runtime could be easily attacked by a hacker or accessed from an unauthorized access like root access, and by that we will have to implement the Intel software guard extension, which is a technology from Intel offers you to create a trusted executed environment. In this scenario, it is called an Intel SGX enclave for process the data securely. So by that, every function of code data inside that enclave will be secure run, and no one can access it from outside. Imagine how they exchange the buffer between the trusted component and untrusted component. The trusted component or the enclave here. Imagine this is a room of yours, and when you call someone from outside, then this is an out call. And if someone call you from outside, then it is an enclave call or the e calls. And however, due to the limitation in each enclave memory size, we will like 64 megabyte to 128 megabyte. Not only the function, not all the function runtime could be pushed inside the Intel SGX enclave, but only a small part of it. So that will have to go to our contribution to understand the Nline workflow and use Intel SGX SDK to migrate part of them into the enclave for enhanced security. After a few weeks of investigate the Nline, we figure out that the local message queue, which exists in each function compartment, and the restore heap, which store the update JavaScript in context used to execute JavaScript function, is critical component to push into the enclave. And after that, we have this workflow diagram here. So first, in the untrusted zone, the initialize part is create an enclave and set some default global variable and a small space for the object JavaScript context. And when the main reactor is called, it will clone function with a default state inside the enclave and process it until it receives a by state, and it will destroy the enclave and end the function workflow. By that, we have in detail. First, we have to modify the Docker file. The Docker file in charge of creating containers that will have to make the in charge of make a container. This container in charge of having a function runtime and when we modify this Docker file, we will have the container to adapt to the Intel SGX. Next, we migrate local message queue and the restore heap to the Intel SGX enclave. When we do this, we have a small problem that the adaptive JavaScript engine not support the Intel SGX, so we also have to modify the adaptive JavaScript engine so that it could execute the function inside the enclave. And finally, we have to make some interface, the echo and echo for transmit buffer outside the untrusted zone and inside the enclave, the trusted zone. So after we have implemented the basic way to know how we improve the performance is we have to evaluate to know how the trade-off between the performance and the security implementation. As you can see here in the graph, this number is taken from the table that in my thesis. We run this experiment 3 times, and you could see this stably. We have a 0.5 second to 0.7 second performance overhead compared to the original align. In a previous work of Intel, which integrate Intel SGX into an open source FaaS model. This is an acceptable reason since such work will happen 0.2 to 0.4 seconds overhead. So what we have done, we have integrated Intel SGX to Enlighten and enhance we assume that we have enhanced the data security, and when we achieve the acceptable performance overhead for added security, however, due to the limitation in time, the service hang-up is the service after execute the first instruction is hang up, and currently also enclave is sharing a private key file, which will not save when we expose that to outside. And currently only data address is secure. So in our future work, we'll implement distributed keys for different enclaves. This key will be generated by code, and this will have to boost the security up. And we have to port the share message queue or the Redis message queue to Intel SGX, so it will protect also the data in chassis, which is the data we use over the internet. And and this is the end of my presentation. If you have any questions, please ask me.